Started. Cool. Okay, so I'm not going to go over the previous homework. I know some people are still working on it and are behind a little bit. And it's obviously had a more open-ended solution because you could add whatever you wanted to it. So I will not go over the previous one and just let people continue on if they need that. We're going to consider the game done once you're done with that. I know a couple people have posted their GitHub repos. Some people are cloning it and playing it, which is fun. Getting more used to Git as well at the same time, and NPM, because you have to install the other people's dependencies when you play them. So I encourage you guys to do that as well. Even if you're not done yours, you can always clone someone else's and play it. It'll get you running Git commands. It will get you running NPM commands. It'll get you running their scripts and seeing what they've done. You can look at their code to see what's running where. And yeah, get used to looking at other people's code. So moving on, we're doing exercises now. So you're going to have the weekend to do this. Next thing is going to be Monday night. So you got Saturday, Sunday, and Monday to complete exercise. We're going to go back and we're going to use a lot of the stuff we know to keep reinforcing it. We're going to do 2 batches of exercises. This is the first batch, then we'll do another batch. And really just so we don't keep moving too fast and keep introducing new stuff all the time. So we can go back and, we're going to write for loops again and all that kind of crap. Just more complicated. So we're going to combine everything we know. We're going to create a new repository, exercises, and then folders individually to complete each of the exercises. So here's this little description of the folder structure. You guys don't need to write any of this down because I'm going to get you guys to do you're going to basically take my Git repo that I've pushed up, and I'll show you how to do it after. But the exercises are using the prompt. The first one is using the prompt promise NPM library. Ask the user a math question. An example, what is 5 plus 7? Verify the user has the provided answer. If not, tell the user it's incorrect. The user can have a maximum amount of guesses of 3. After that, they can no longer guess and the program should exit. If the user is correct, let them know. The program should exit successfully. So that's just reusing that same prompt promise library we just used, but now we're going to deal with just a really quick exercise on dealing with a user's response and verifying it's correct, but then also implementing this sort of maximum guesses logic, so throwing a slight wrench into it. It's going to be a lot simpler than the game, but it's still going to be like, how do you use the prompt with, while the guesses are less than 3, basically. The second one is going to be writing a function that takes a minimum number and a maximum number, and using a for loop, log out all odd numbers between the min and the max, not including the min and max themselves. So we've done for loops, we've done this kind of odd number thing, but I'm adding some constraints in here to really make sure you're doing exactly as to be expected. So, if I pass in 3 and 100, it's going to start from 4 because we're not including the min or the max, and it's going to go to 99. So it's going to log out 5, 7, 9, 11, blah, blah, all the way up to 99, but not 3 or 100. Next, we're going to mock out some functionality of Steam. We're going to declare a class game. This is largely similar to what we've been doing with the classes. We're going to declare a class game, takes 2 arguments in its constructor, name and price. I'm going to create 5 different games. So this is largely like we did with, creating spells and then creating 5 different spells, or creating mobs, creating 5 different mobs, weapons, creating 5 different weapons. That's sort of make a base class and then create some examples. Then we're going to declare a class, Steam user, that takes 1 argument in its constructor, its balance, and sets its property on the user, as well as the empty array game. So a Steam user has money, their balance, and a games array, which is empty at the start. We're going to write a function on the Steam user class that lets the user purchase a game if they have enough balance to afford the price of the game. If they cannot afford it, throw an error. Write a function on that Steam user class that lets the user wishlist a game. If they already own it, throw an error. You cannot wishlist a game that you already own. You're going to write a function on the Steam user that logs out a user's games alphabetically. And then changing that function that we just wrote to log things out alphabetically to take an argument, sort type, to let the user decide to sort them alphabetically or by price. So then you can make that function work like that. So that's going to be one of the first examples of writing a function and then refactoring it after to add more functionality. So we're going to write the base one is sorted alphabetically, all the users' games. And then afterwards, we're going to go back and say, actually, we need some more functionality in that function. Let's let them sort them by other factors than then alphabetically by name. We can also sort them by price. And then, so that's going to be the whole Steam one. So we've got using the prompt promise package, user input, dealing with that. A while loop is going to be involved there. We've got this for loop function that takes a min-max number and logs out all the odd numbers, not including the min and max. So working with constraints within a for loop. We've got the Steam thing, which is largely similar to the Discord and game models that we just used, mocking out classes to represent real world things. And then functions on the classes let us do stuff with those things. And then the fourth one is going to be basically brand new. I know some people have tried this a little bit already, but we're going to monitor Ethereum activity in real time. And we actually know how to do this already. You might not think you do, but you do. There's quite literally nothing new here, which will really, I think, kind of drive home how this stuff is really used in the real world, not just really stupid terminal games, but like actually doing it. So we're going to sign up for a free Infura account. I'm not going to explain too much of what this stuff means. I'm going to let you guys Google it and figure it out, which is the goal. Sign up for a free Infura account. It's an Ethereum node. Then using the Ethers NPM library, because we know how to install NPM libraries, just like prompt promise, we know how to install those Ethers. We're going to display the following information: the current block number, the current gas price, the current chain ID. And then using the prompt promise library, so now we're combining two libraries, Ethers and prompt promise, prompt the user to provide an Ethereum address, and then display the Ethereum balance of that account to the user in the terminal. If it's not a valid Ethereum address, display an error. So you'll have to use a validation function. The balance should be converted from Wei to Ether, because the balance will come back in, the smallest denomination of Ether, Wei, and you need to display it to Ether. So if I get 1 to the power of 18 back, I need to display that as 1 Ether, not the 18 quadrillion bazillion Wei that it comes back in. User readable format. And then we're going to display the transaction count of that user. Oh, I can format these a little bit better. Then we're going to display the transaction count of that account in the terminal. So if I've sent 20 transactions on that address, I should display this user as 20 things. So if we kind of go look at how I would tackle some of these things from the get-go, right? Moving on to the exercises, I know I have this exercises folder, and I've got one, and they're all separate, right? 1, 2, 3, and 4 are 4 different things, and they've got some sub things here. So what I would do is I would just make a folder over here in my exercises and call it like 1. Actually, I don't need the dot here. That's stupid. Make it 1, and I would do all my 1 stuff in there. So I would, ask the user a math question. What is 5 plus 7? So maybe I'd make like, math.js or something in 1, and, start off and just be like, okay, function, prompt and solve math, something like this. And then, go up here and say, oh, I've got to go down to my terminal and be like npm install -- save prompt promise like I did before. Doing that in the root, not in the 1 folder, but in the root. And then noticing that, yeah, I installed it, but I don't have an package.json here because I didn't run npm. So I'm going to run npm init, We did that before as well. Starting off with our package, getting the package.json. Add it to Git, etc., and then do all the exercises in their individual folders. So if I'm in a subfolder, I can still do like that, like require stuff from the root. Then I would move on, finish that, get it running, and then create a new folder 2 and solve the second bit of homework in there, that kind of thing. And then when I get to the Steam one, there's going to be multiple classes, multiple things. I would probably make a 3rd folder for the Steam stuff, and then I would have that in separate files like game.js, and then maybe like steam user.js, and then like main.js for like actually like running my app. Like however you want to organize it's fine, but that's what I would probably do, is keep them separate, not just have them all in the root, because then you get used to the goal is to get us we're doing repetition, right? So rather than taking shortcuts and just having it all on the root and be like one.js in the root folder here, I'd probably try and get used to this folder structure thing a little bit more, because that's the whole goal. We're trying to get familiar with all this. We're just gonna keep kind of drilling this in. And at the same time as we're getting familiar with stuff, we're going to be adding some new stuff in, which is like using ethers. But we're not actually doing anything new syntactically with the language. We're just doing something we haven't done before logically. But there's no new keywords or anything you need to actually, like no new programming methods to do any of this stuff. We know how to do all of this actually. Which is quite cool. So if I was going to start the ethers thing, and be confused about that, I'd be like, wow, I've never done that before. I would, go to, they said it's called ethers, and I would be like, ethers JavaScript. And there's stuff here, and then like ethers JavaScript example, and then like how to use ethers Ethereum library or something, or click this code sandbox and see what this guy's doing, and click around until I find some stuff on ethers, maybe just npm ethers. To see, I can click it on npm.js and scroll here and be like, it tells me how to install it. npm install save ethers. And then maybe if I need to display balance using ethers, because that's one of the tasks. Here's a guy asked that question. Here's a Stack Overflow, which you'll be very common of, right? And you'd be like, this guy showing me how to do it here. And here's a blah, blah, more stuff. Read around, try. The whole point is to get you Googling, getting you figure it out, not getting the AI to write it for you, not copy pasting, not stealing my solutions, because I'm not going to do them until after. I'll do them all live in front of you guys after, but I'm not going to do them now. So there's going to be no code for me to follow along with. This is going to be you guys actually just doing it from scratch. So what I've done is I pushed this up actually to GitHub. Called it exercises. GitHub.com Cyberhorsey exercises. And you guys will be able to visit this URL, which I'll paste in the announcements. And this is how we're going to start doing the assignments from now. It's all on Git. So I've started this. And in the same way, I'll go to a repo that I don't own to kind of show you the example. Like a work one. There's this thing up here where it says fork. This means take this guy's repo and put it under my name. Fork it. Fork the code. So if I say like GitHub ethers, I'm just going to show you an example. I'll actually fork something. Whoops. GitHub ethers. Doesn't really matter what this library is, but if I go up here and I click fork, create a new fork, and it's under Cyberhorsey called ethers.js, and I can create a fork. And now you see I have Cyberhorsey/ethers.js fork from this. This is a way to basically take someone's open source code and put it under your name. So if you go to that repo that I linked, see now I have a full repo, like I own this, and I can do whatever I want here. I can push to my own thingy. I can't go back and push to theirs, but now that I have it forked, I can treat it as my own code as if I wrote it from scratch. So you guys will be able to do the same. You'll be able to go to github.com Cyberhorsey exercises as I linked, go up to the forks, click create fork. I can't do it here because it's my repo, but then you'll have your own copy of it, which is cool. And then you can click to the green button here to clone it, and you'll be able to clone it. So I take that link and I go here and say, I can say git clone, paste the link, cloning in exercises, boom. And I can see the exercises, because that's cloned in the name of the repo. And I have my pushed repo. But it points to the one that I forked. So, if Neil goes and forks this, and it'll say /nightjob/exercises, and he forks it, it's his now. It's just like, it's a way for me to basically start you guys off with templates from now on. And it's also a way for you guys to maybe share each other's code, because you guys will have to clone it a little bit and stuff. So for the start of the exercise, everyone should go and fork github.com/cyberhorsey/exercises. And then all the instructions are in the README. And when you add code, you fork it, clone it. You got it here. Then you do git add dot git commit dash m blah blah git push origin main to push it up, and that'll push it to yours, not to mine, because you forked it. It's now yours. So we're going to get very used to that process in the future, because we're basically going to be doing that constantly at the beginning of every lecture now. And we're going to start integrating these Git and NPM workflows just into our daily routine, so they become less intimidating and less confusing, because the Git is very confusing at the beginning. Even if you learn how to program, Git is its own thing. So a lot of people wait to learn Git, but I find it's better just to start off with it, because it's just so important. From the get-go. And the same with NPM, right? These are things that if we start integrating them into our workflow, no matter where we're at programming, we're going to be simultaneously developing these skills, which is cool. And then we're also going to be simultaneously developing the skills to research. So, me not doing the ether stuff in front of you. You'll be able to ask me for help, ask anyone else for help. I know some of us have already done this stuff as well, because they've just done it as for fun when I gave random assignments. So if you want to ask for help, there are some of us who've already kind of done a couple of these things. There's also going to be a bunch of different ways to accomplish it. So you'll have to really, practice your Google foo and figure it out at the same time. None of it's very difficult or hard, but it does combine a lot of things that we have done for maybe once, in one lesson. We've had one lesson on NPM, and now you're going to do a package you've never used before. That's basically where we're at. And then we're going to do another set of exercises afterwards that just literally learning nothing new again, doing the same thing. So if this is daunting and you find it hard to go back to older stuff, then this is perfect, because this is exactly why we're doing this. Going back to being wow, I just wrote a while loop in my most recent homework and I can't remember how for loops work. This is, kind of why we're doing this. Getting used to declaring classes, getting used to declaring different functions, using them together, throwing errors when stuff goes wrong, validating stuff. The whole goal is, I know most people are probably very confused by the base stuff yet. So we've learned enough now to piece together to actually sort of stop learning for maybe a week and just go hard at it. I think that's pretty much it. Short little lecture Friday night. Any questions? Absolutely none, hey? Easy mode. Okay. Pause the thingy.